Ooh, haven't done this. Interesting. Interesting. All right, let's think about this. Got this array. We're saying there's all these robots all over the place. We get to choose what direction they go. And then there's going to be, let's say, like some places for them. So here, maybe we would want this robot to go this way, this one to go this way, this one to go this way. So, okay, what's the constraints? Robot.length and factory.length are both 100, so I can get away with O of n cubed. I'm almost thinking that like the one way I could set this up is like dp at I for the ith robot at something. And then what this could mean is try to make this robot go left or right. So it's O of 1 transition to do that. You're just making a choice for every robot. That's like one immediate sort of like intuitive thing for me. But I don't know that it's that simple. I mean, maybe it's like... Maybe I don't do that though. Maybe I go by the stations, the factories, and I say, look at this one. Let's say this has 2 available. Does the number available for the factory always match up? No, I don't think so. Okay, so 0, limit at j could be 0. Yeah, what if you went factory by factory and you said, okay, this let's say has a limit of 2. You could take one robot, you could take another robot, and so on. Yeah, that makes sense to me. And then you would keep track of which robot index you're at, because as you increment forward, okay, yeah, that makes a lot of sense. So you would say like, let's just draw a new one, a little more clean. So the factories, let's say, are there, there, and there. And let's say this has like 2, 3, 2. And then for robots, we have like there, 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 there. So then here we can take 2. So maybe we say, okay, well, let's take this robot and this robot. We can immediately get the distances for those. And then we would like increment up. So now like j is 0 and now I is 1. And then we would go here, we would say, okay, cool, now we're done with this. Every time we take a robot, like try incrementing j. So then here we would say there's the world where we only took one robot here. And now we need to take like this robot, and this robot. Or like just these 2, or just this one, or none of them, I guess. And then you would keep moving up. And at the point where you're at any given x, say this middle x, you know that you're always going to want to take whatever the amount are taken here. Those are already handled. You're always going to want to take them in ascending order if you're taking the factories in ascending order. Because there's never a world where you would want to take a robot from over here. That's never going to happen, because that could have been better used for something down the line. So this is your best bet for using something earlier. And then there's a world where, like, let's say this was, 2, 3, 2. Then you would take this one, and also this one would go backwards then, and you would still just get the absolute distance. So then your DP state would be TP I, J. And then the transition's just O of n, because you would try each of these, and then this would lead to n other DP states. That checks out. A little smiley face. Sweet. Okay, so this should actually be quite easy to get on one line, but first I'm going to get it iterative. dp equals blank for I in range n 0 times j, although I'll have this be infinity times j. Time for the one-liner. Return a dot sort b dot sort n colon equals length of a, m colon equals length of b. Okay, pretty good so far. I think I can save a couple characters by doing that. I mean, so what I want to do is just say like lambda, who cares? Or no, I could just have repeat, right? I think repeat is what I want. So it's going to repeat n times. The thing that's going to repeat n times is just infinity times m plus 1. So far it's exactly what dp is. And then we need to actually go through with like a big map and modify everything. So map something range m minus 1 minus 1 minus 1. Okay, we got to actually like have this actually map it instead of just saying that it can map it. Lambda j map something range I, not range I, range n, lambda I, and then one more. But maybe I can be smart about this. I think I can just take a minimum. I think I could say min map lambda k all of this. Or what I could do is I could try and be fancy with a reduce. I could say reduce all of this to be the aggregate minimum. And the advantage of reduce as opposed to min map is I could keep track of D easily, because if I map it, I have to do something that's like D colon equals something, and I probably would have to have this be like D is 0 and then D dot append D dot pop, and that sounds like a nightmare. So I'll say reduce something range, and I'm just going to copy this because I kind of forget what this thing is. Okay, it's going to be the range here, but I need to actually instantiate an initial, because it's not just going to be like addition or something. It's going to be initial equals, I'm going to say the initial D, the anime, is 0. The initial minimum so far is dp at I at j plus 1. So that's like we're sort of doing this without having to explicitly say it. That's the initial state. And then here lambda, we'll say p for prev, k for the current index. So it's going to be a tuple again. The distance is going to be p at 0. So the previous distance plus all this. And then minimum of p at 1, so the aggregate minimum so far, and dp at k plus 1 at j plus 1 plus d that we've set here. That looks pretty good. And then for this whole reduce, and now it's going to return a tuple, and I just have to say, okay, now return the first thing. I set D there. I have to imagine it's on this line, because I can't imagine I reference D anywhere else. So it is certainly this line right here, which is weird because the very last thing that I did was set D to be something. Oh, but I think it's like I included one too many parentheses. I think it's like I need to get rid of these. Okay, we're getting somewhere. What if okay, I think maybe I know the problem. It's that repeat is not doing what I want it to do. I think this is actually what it is. Repeat, I thought I was so clever getting that without a list comp, but I think what's happening is repeat is setting everything to be the same row repeated. Like this is not just the same values, but the same row itself. So one thing I could do is map lambda blank infinity times m plus 1. I guess I'll do that to start, just to make sure that it like works. Okay, now it's giving real results, which is what I want to see. And I don't know why I said -1 here. It's 0 0. Okay, so now it is all on one line, but I want to see if I can get rid of this lambda because it's somewhat unnecessary. The other lambdas must happen. There's just no way. But this one, I could probably get rid of it. I'm trying to make a 2D array. How do you do that without a lambda? This seems like actually kind of rudimentary, or at least like it's good to know. No, I've got it. I say map partial multiplier infinity. So you're going to multiply infinity by something, and then this is no longer range of n. I actually changed this to be repeat m plus 1 n. So it's going to repeat m plus 1 n times. Whew, man. Something I could do too is instead of and dp at 0 0, I could just say at -2 at 0 0. Or what is this, like a 4? 0, 1, 2, 3, 4, yeah. So I'm saying like, and just yank the dp expression from that. That was a good one. I hadn't done this problem before. It wasn't the hardest hard. I'm surprised I hadn't done this before. But this was good to get on one line. The reduce was really, that was like actually the cool part here. See you next time.